Hello class, this is a video tutorial on annuities as a geometric progression, example 1. An annuity is an investment that requires regular contributions at regular intervals. Each contribution accrues compound interest for differing lengths of time depending on when the contribution was made. So to fully understand this, let's go straight into an example where we calculate this. So Greg's parents invested $1,000 on the day he was born, and again on every birthday until Greg turns 20. If the annuity earned 7% per annum, compounding annually, how much did Greg receive on his 21st birthday? So let's first consider this as a compound interest formula for the original $1,000. So our principal would be 1,000. Our rate is 0.07. And the length of the first investment, well, if it's from when he was born until his 21st birthday, that is n equals 21. So the value of the first investment from when he was born will be $1,000 times 1.07 to the power of 21. So that is the value of the first investment from when Greg is born. But when Greg turns 1, his parents put in another $1,000 at the same rate, but this time this investment will only go for 20 years, because from when he was 1 year old until he's 21 is a difference of 20 years. We can do for the third year, it's 1,000, 1.07. This one will only go for 19 years, and this will continue until we have the 19th investment. The 19th investment will be $1,000, 1.07 to the power of 2, because it'll be 2 more years until he's 21. And on the 20th investment, on his 20th birthday, when they stop, be $1,000, 1.07, and this will only get compound interest for 1 year, or just that expression there. If we were to try and add all of this individually, we'd be here forever. So let's consider this as a geometric progression. To find the total for this, we're going to add all the expressions. So this first one, A20 plus A19 plus ... A2 plus A1. To make this a lot easier, I'm going to express 1,000 as just P. So P outside of 1.07 to the power of 21. We're starting from this one here. To the power of 1 plus P outside of 1.07 squared plus ... P outside of 1.07 to the power of 20 power of 21. Since every single expression here has P as a common factor, I'm going to factor that out and write all the expressions again. So let's erase P because they've been factored out. I hope by now you can see this as a geometric, what happened there? Hope you can see this as a geometric expression inside this square bracket here. In case you don't see it, it'll be P outside the sum of this expression. I hope you can see it. I'll outline it here. The first term is 1.07. The common ratio, don't mistake this R for the R in the compound interest. This R is if we take any term and we divide it by the previous term, well, this will get us 1.07. And our N value, how many terms are inside this orange bracket? Well, that is 21 terms. Also, I hope you remember the sum of a geometric progression. In case you've forgotten, it's A outside of outside of R to the power of N minus 1 all over R minus 1. Substituting our values in, we get 1.07 outside of 1.07 to the power of 21 minus 1 all over 0.07. Taking this expression and substituting it in to S of N. Oh, putting our values in now, this is going to be 1,000 outside of, making it nice and easy for us here. Let's just duplicate this. There we go. And it's this value that we would like to evaluate into our calculator. So here we go. 1,000 outside of 1.07, 1.07 to the power of 21 minus 1 all over 0.07. Hopefully this calculator evaluates it correctly. There we go. And this equals 48,000. And rounding up to the nearest whole number, $6. So I hope you see what an annuity is, where we're contributing the same amount every single year, but each contribution gets compound interest for different lengths of time. From here, I hope you saw that we could take the sum of all of this and it becomes a geometric progression that we can find the sum of. I hope to see you in the next video when I do another example. Best of luck!